Good morning, guys. It's been a while since we've uploaded a video, but I've been looking at what we need to go back and look at. And today for Algebra 1, I'm going to go back and look at factoring trinomials, but doing it when there is a leading coefficient. What's in front of x squared is 1. We're going to start with the basics, starting with factoring with leading coefficient of 1. We'll do that today. Tomorrow we'll look at a leading coefficient other than 1 and how that changes our steps just a little bit. And then we'll look at how we need to use that as we progress towards what you're going to be doing in Algebra 2. So let's get started with this. Okay, let me find my page here. All right. So here we go. Now, there are steps to follow when we do this. The first step is always to make sure it is in proper form. So we've got ax squared plus bx plus c form. Okay, now does it always have to equal 0? No, but sometimes it will because we'll talk about roots. So the next thing we're going to look at is, does it have a GCF? Most of the time, it doesn't when they're started out like this. Okay. The ones we're going to work with today probably don't, because I'm going to start out with a very straightforward example. All right. So now we're going to look at our problem. And we're going to identify our A, our B, and our C. So if I have x squared plus 5x plus 6, I can always put a 1 in front of the x squared, because there is always a 1 in front of any variable that doesn't have a number, a coefficient in front of it, a number in front of it. Okay, so that's my A, and that's my B, and that's my C. Now, we're going to take C, and we're going to find sets of factors of C. So what numbers can I multiply together to give me 6? So let's look at this. 6 can either be 1 times 6 or 2 times 3. Now, we want to identify the set that either adds or subtracts to get B. Okay. So which one of these will either add or subtract to give me 5? Well, 1 plus 6 is 6, or is 7, and 1 minus 6, you're going to get negative 5. Okay, but I want a positive 5 here. 2 plus 3 gives me 5. So those are the two pieces I'm going to use. Now I'm going to take and I'm going to split B, into its two factors. So I'm going to rewrite this as 1x squared plus 2x plus 3x plus 6. So I've taken 5x and I've split it into its two pieces, 2x and 3x. Now we're going to look for common factors in small groups. What do I mean by in small groups? What I mean is I'm going to take the first two pieces, make them one group. Do they have a factor in common? Let's look. I've got x squared and I've got an x and I got a 1 and a 2. Well, I know I can take an x out of each of these, and that'll leave an x behind and a 2 behind. Okay, so now I've basically undone some multiplication. Now let me look at the other two. What do 3x and 6 have in common? Well, they can both be divided by 3. So if I take a 3 out of this, it leaves the x behind. If I take a 3 out of this, it leaves a 2 behind. Now, I'm going to repeat this process because look at what I have here. I have a 2x or an x plus 2 here and an x plus 2 here. If I take that out, what do I have left behind? I have an x plus 3. Now, I have factored completely x squared plus 5x plus 6 into x plus 2 and x plus 3 times x plus 3. Now, is there a way I could check this? Yeah. I just do my FOIL again. If I FOIL this, what's going to happen? Well, x times x is x squared. X times 3 is 3x. X times 2 is 2x. 2 times 3 is 6. So I'm going to find all my pieces that I already started with. So let me find a problem for you to work. Okay, should have had this ready before I started this. All right, here we go. So here's what we're going to try now. We're going to try a squared plus 11a plus 30. Now, don't let the size of that number scare you. We're still following the same ideas we just did. Okay, so if I look, here's my A, here's my B, here's my C. Now, I need numbers that are going to multiply together to give me 30 and either add or subtract together to give me 11. So let's see. Possibilities for 30. 1 times 30, 2 times 15, 3 times 10, 4 doesn't work, and then 5 times 6. Now I need 11. Since this is positive and this is positive, I'm going to be adding. Well, let's see. 1 plus 30 is 31. That's not what I need. 2 plus 15 is 17. 3 plus 10, 13. 5 plus 6 is 11, so this is what I'm going to use. Now I'm going to rewrite my center piece with what I just found. So now I have a squared plus, see, I'm going to do 6a plus 5a plus 30. Now, why did I flip-flop the 6 and the 5? Well, look, 30 and 5 can both be divided by 5, so why wouldn't I put them together? I've already setting myself up to make my factoring a little bit easier. So now let's look. Do the first half. Do a squared and 6a have anything in common? They have an a in common. So now when I take the a out, I have an a left here and a 6 left here. Go to this half. What do these two have in common? They can both be divided by 5. That leaves me with an a, because 5a divided by 5 is a. 30 divided by 5 is 6. Now, what do these two pieces now have in common? Well, they have a plus 6 in common. So I take that out. And in a new parentheses, I write what I have left behind. That's the basic mechanic of the factoring anything. Now, are we always lucky enough to have both pieces positive? No, we're not. So we have to look at what happens when we don't have both pieces positive. So let's try another one. Get my handy dandy interactive notebook. So let's see, this time we're going to do x squared minus 11x plus 28. So let's see what happens here. All right. Well, I got my A, my B, and my C. I'm looking at 28. Numbers that multiply together to give me 28. And this time add together to give me negative 11, because that sign's important. So am I going to really be looking at things that add or things that subtract? Well, adding and subtracting are pretty much the same thing. I know it doesn't sound like it, but it is, because subtracting is just adding opposites. But you know, that's a whole other video. So let's look at this. We want numbers, we want sets of numbers that multiply to 28. Once we have that, we want a set of numbers that will add or subtract to give me negative 11. So 28 is 1 times 28, or 2 times 14. See, 3 will not go into 28. 4 times 7. 5 won't go in, 6 won't go in, 7 won't go in. Okay, I'm all the way to the bottom. Now, 1 and 28. 1 plus 28 is 27. 28 minus 1 is 27. So I either have 29 or 27. That's not going to work for me. 2 plus 14 is 16. 14 minus 2 is 12. Now we've got a problem here. 4 plus 7 is 11. But how am I going to get a negative 11 here and a positive 28 here? What would happen if I said negative 4 minus 7? That would give me the negative 11 I wanted. And then let's look at this. Negative 4 times negative 7 is positive 28. Does that give me the two pieces I want? It does. So now let's take that and put that in our problem and see what happens. So I've got x squared minus 4x minus 7x plus 28. Okay, I split my b into its two pieces. Now let's look at for common factors in our pieces. Well, I've got x squared and 4x. So I could take an x out of them and leave me with x minus 4. Okay, negative 7x and 28. Well, I know 7 times 4 is 28. But do I want it to be a positive 4 or a negative 4? If I look right here, it'd really be nice if it was a negative 4. So if I take a negative 7 out, it makes negative 7x divided by negative 7 becomes positive 1x. And positive 28 divided by negative 7 becomes negative 4. Now, if I look down here at what I've done, I have negative x minus 4s in both of these. So I can rewrite that, take it out, and write down what I have left, which is x minus 7. Now I have completely factored x squared minus 11x plus 28 into its two pieces. So this is possible. You just have to be really careful. Are you going to run across numbers that won't do this and you'll have to go to the quadratic formula? Absolutely. But for right now, the problems we're going to work with, we'll have a way that this works out. So let's try another one. Let's try x squared minus x minus 90. Now, I know y'all, the bigger the number, the scarier it looks. But we take every number just the same. What combination of numbers can I multiply together to give me 90? and then add or subtract to give me 1. So I've identified my A, my B, and my C. And this is the hard part to remember. Those signs that are in front of our numbers stay with our numbers. So I'm not just looking for numbers that multiply together to give me 90, looking for numbers that multiply together to give me negative 90. So do I know which one's positive and which one's negative yet? No, but I'm going to make myself a little note up above it that a negative times a positive is what gives me a negative. That's going to be one of my clues that I work along. Well, 90 could be 1 times 90, or 2 times 45, or 3 times 30. See, will 4 go into 90? Let me see. 4 goes into 9 once. No, twice, with 1 left over. But 4 doesn't go into 10, so I can't use that. All right. 5 goes into 90, 5 goes into 9 once with 4 left over. 5 goes into 40 8 times, okay. 5 and 18. Okay, 6, will 6 go into 90? Let's see. 6 goes into 9 once with 3 left over. That means 6 goes into 35 times. All right, okay. Well, will 7 go in? No. Will 8 go in? Nope. 9. Well, 9 goes into 90 10 times. Okay, we have a bigger list to check out this way. Now, we have another hint right here. This is negative 1x. So when I do my adding or subtracting, which number should be the bigger? All right, which number should be the negative? The bigger number or the smaller number? Well, if my answer is negative, the larger of the two numbers when we look at absolute value would have to be the one that was the negative. So I'm going to go through and I'm going to put negatives on all my big numbers. Now, as I go down through this list, which one of these is going to give me negative 1 as my answer when I add or subtract them? Well, 1 minus 90 is negative 89. That's not going to work. 2 minus 45 is negative 43. Definitely not going to work. 3 minus 30 is negative 27. 5 minus 18 is negative 13. We're getting closer. 6 minus 15 is negative 9. 9 minus 10 is negative 1. This is the one I want to use. Okay, so let's put it in. So this becomes x squared plus 9x minus 10x minus 90. I look at my first two pieces. They have an x in common. When I take the x out, it leaves an x plus 9 behind. Now, look at my second half right here. Negative 10 minus 90. If I take a negative 10 out of negative 10x, negative 10x divided by negative 10 is x. Negative 90 divided by negative 10 becomes positive 9. Now let's look. I have x times x plus 9 minus 10 times x plus 9. Well, I said x plus 9 both times here. So I can take that out, write it so I know I took it out, and then write down what I have left, x minus 10. So x squared minus 1x minus 90 becomes x plus 9 times x minus 10. Now, just because it looks hard doesn't mean it isn't. It is. Sorry. Just because it looks hard doesn't mean it is. It just means you have to take your time and do your steps piece by piece. Now, I'm going to put one up and I'm going to give you about 3 minutes to try and get it done, okay? Following the steps that we've already done, I want you to take x squared plus 3x minus 70 and factor it. Make sure you show your work and show your reasoning, okay? You've got 3 minutes. Okay, guys, so let's look at this. I have my A, my B, and my C. So I'm looking for two numbers that multiply to give me negative 70 and add together to give me 3. Well, to get a negative number multiplying, I have to have a negative times a positive. And because my number in the middle is positive, the larger of the two numbers when I factor is the one that's going to be positive. So I'm going to be putting my minuses in front of all my smaller numbers. Well, negative 70 can be negative 1 times 70, negative 2 times 35. See, will 3 go into it? No, 3 won't. Will 4 go into it? No, 5. Negative 5 times 5 goes into 7 once. 5 goes into 24 times. Okay, 14. 6, no, 7, negative 7, and 10. Okay, that's as far as I can go. So let's see here. Negative 1 plus 70 is not going to work. Negative 2 plus 35 is not going to work. Negative 5 plus 14. Let's look. Negative 7 plus 10 is positive 3. That gives me what I want in the middle. So this is the one I'm going to use. And I'm going to do x squared minus 7x plus 10x minus 70. Okay, now I'm going to put these two together. What do these two have in common? They have an x in common. So now I'm going to take out an x. X squared divided by x leaves x. Negative 7x divided by x leaves negative 7. Now look at these two. 10 and 70, what do they have in common? Well, they both end in 0, so they have to be divided by 10. They can be divided by 10 if they both end in 0. Awesome math fact. So I'm going to divide both pieces by 10. 10x divided by 10 is x. Negative 70 divided by 10 is negative 7. Now let's look. I have an x minus 7 here, x minus 7 here. So I'm going to take that out. And what do I have left behind? I have x plus 10. All right, guys. Now, you can go out there, you can type in any search engine you want, and you can type in factoring trinomials with a leading coefficient of 1, or just factoring trinomials, and put in factoring trinomials worksheets. It will pull something up. You know what you're looking for. Take this video, take these clues, and go practice. If you've got any questions, please remember you can always email me, and I will answer the questions as best I can. Have a good day, guys.